This was the one for warm-up, so this has happened before Irma. We didn't get to do this one, okay? You're graphing each function. This is based on your transformations. I would say if there's a function on here that you also don't know how to find the domain, the range, the increasing, decreasing, max, min, anything like that, that's stuff you want to make sure that you know. With the exception of like the square roots, you're probably not finding there's not going to be a max because it keeps going up, or a min that keeps going down. But the rest of them all have a max or a min. And then all of them have domain and range. All of them have increasing, decreasing behavior. So you should be able to find out all that stuff based on your graphs. All right, so 1 is f of x equals x squared plus 3. What does that graph look like? What's the parent function?
Parabola.
So if I write out the parent function, it would be f of x equals x squared, okay, or quadratic. And then what's the transformation? Nope, up 3, good, 1, 2, 3, and it opens upwards. So with transformations, again, just an approximation. You don't have to give me anything exact other than the vertex. Domain there would be all real numbers. Range would be from 3 to positive infinity with a bracket on that 3. It's decreasing from negative infinity to 0 and increasing from 0 to positive infinity. And both of those zeros get the parentheses. Is this even or odd? It's even, right? It's actually symmetric to the y-axis this time. Everybody sees that? So this would be an even function. Nope, go down. Okay, so 2 parent function, f of x equals the square root of x. The shift inside the function does what?
It goes 1 to the right.
Good, right 1, and then the minus 4 would be?
Down 4.
Down 4. I'm going right 1, down 4. Square root points up and right. Domain on this one is 1 to positive infinity with a bracket on the 1. And range is negative 4 to positive infinity with a bracket on the negative 4. So domain is your x, range is your y. And it's increasing from 1 to positive infinity, okay? And it's not either even nor odd. Questions on that one? Okay, 3. My parent function is? Good. The absolute value of x. This goes left 2. This goes down 3. So I'm going left 2, 1, 2, 3. Put a point. This opens upward. Domain is negative infinity to positive infinity. Range negative 3 to positive infinity. It's decreasing from negative infinity to negative 2. And then increasing from negative 2 to positive infinity. And it's not even nor odd. We still good? Any questions so far? Okay, 4. Parent function, f of x equals x squared. Or a parabola. That's really hard to read. The 1/2 on the front does what?
Makes it a horizontal stretch.
Good, a vertical stretch, but it kind of looks the same thing. A vertical stretch, or it makes it wide, right? We can say any of that stuff. So wide, stretched. No, sorry. It'd be shrunk. Stretch would be bigger than 1. Shrunk means like the ceiling and the floor are collapsing in on my graph, right? Which makes it wider. And then the minus 2 here is a down 2. So I'm going down 2, plot a point, and then I would make it wider than my normal parabola. And I would write wide, or I would write shrunk. Something to indicate that that is not my standard shape. Domain, negative infinity to positive infinity. Range, negative 2 to positive infinity. It's decreasing from negative infinity to 0 and increasing from 0 to positive infinity. And this one is even, symmetric to the y-axis. And there's a minimum, right? The minimum is 0, -2.
Like how wide the graph is, or how like in the graph is, do we have to plot that exactly?
No, not for transformations. Yeah, no. So there's a section obviously on transformations in which it doesn't have to be exact. And then there's one where you're plotting your intercepts and all that stuff. That graph should have the points on it. All right, 5. Now a couple of, well, multi-step, right? So this time my parent function is the v, or absolute value of x. The negative on the front does what?
Upside down.
Upside down. The 5 next to it, narrow or vertically stretched. The -1 inside, right 1, and the +2 on the outside, up 2. So odds are, obviously, on a test, we're doing something like this where there's multi-parts, okay? You're not gonna have like one shift. All right, so to the right 1, up 2, there's my vertex. It's upside down and it's narrow. This time domain, still -infinity to positive infinity. There's not going to be a restriction on an absolute value. The range goes from -infinity up to 2, with a bracket on 2. It's increasing first from -infinity to 1 and decreasing from 1 to positive infinity. And it is not even nor odd. And the last one, parent function, square root function. The negative on the inside does what? Over the y, right? So over y, or points at left, same thing. And the +3, up 3. So 1, 2, 3, plot my point. Normally that points to the right, but it's not. It's pointing to the left. Now, domain, -infinity to 0. Range, 3 to positive infinity. Oh, bracket. And this one is decreasing from -infinity to 0. And is not even nor odd. Questions on any of them? Isabella?
On the last one, if the negative was outside the square, it would flip over the x-axis.
Correct. So if the negative was here, now I still go up to 3, but I point it down and to the right. If there was a negative on the front and on the inside, now it would be down and left. So the negative on the front flips it upside down, the negative on the inside flips it right to left.
So on the notes it says that like the flip across the y-axis is only the square root. Is that like the only type of
Technically, if it's a V or a parabola, right, if you flip it left to right, the shape doesn't change.
Oh.
What would happen is if it's always a reflection over the y, but sometimes it doesn't matter. Unless there's so if it was g of x equals, let's say, -x plus 3 squared, okay? So a parabola itself, if I flip it, it still looks like a U. But a negative on the inside changes the sign, or what happens to the sign that's in there with it. Does that make sense? We talked about this before, that wouldn't technically, there's 2 ways to look at it. One, graph my original, which would go left 3, 1, 2, 3, be a parabola like that, and then flip it over the y, which takes it 1, 2, 3 to here. And that would be your final graph. Or take this sign and make it change that sign. Because if I actually solve that expression, which is what we're doing, like that's what we're doing it as a shortcut. I solve that expression, it becomes -3, but then it becomes +3, which means I would shift it to the left 3. And then I would not no, I would shift it to the right 3, sorry. Change it so that it would be a minus on the 3, which really shifts it to the right. And then I wouldn't have to flip it over the y. So either way, whether I shift it without changing the sign in the parentheses or I let it change the sign in the parentheses, you should end up with the same graph. And again, when in doubt with these, you could always plot a point, right? Like you could have plotted, I didn't know what was going to happen and I plot 2, I would know where that point was going to go. It's just that for these especially, hopefully you don't have to waste the time plotting the points because these should be quick questions. There's plenty that are going to take a little bit longer. These should be quick. All right, so any other questions on all of 1-4? And then obviously you can use the knowledge of 1-4 to help you with a lot of other stuff. You should know what the shifting looks like if it's in standard form. And when we get into, back into chapter 2, it certainly is going to help you with your quadratics. All right, so this is, remember there's like 3 reviews that you can access. This is one of them. This is on the review assignment. It's not graded because obviously I signed the odd ones and you can check them, okay? But in the very beginning, it goes through like the chapter summary. So obviously onto that, you do want to make sure that you add in the R.1 and R.2. And R.1, remember, was your distance and midpoint. This is where you had to find the lengths of the triangle and then classify it. All that stuff was R.1. And then R.2 was your intercepts, your symmetry. R.1 was also the circles. So there's like 7 ways to review that. 1, go back to those individual sections. 2, the quiz review that you did, went over all that stuff. 3, the review that I posted last Tuesday when we came back from our little Irma break has all that stuff in it, okay? And then on this slide here, you can see that it goes through 1.1, the formulas you needed from 1.1, which is the midpoint, the slope, or the point slope. It goes over how to find the slope and the y-intercept from an equation. It goes over the parallel and perpendicular slopes. And then it goes through the function notation, so how to find the function, like f of 2 from a graph, from a equation, and the difference quotients in there too. That's all 1.2. And then 1.3, which is the domain and range. You want to be able to do it from a written function, from an equation, and also from a graph. The vertical line test to figure out if something is a function. And then increasing, decreasing, and constant were in 1.3. Relative max and min were also in 1.3. Don't worry about the stepwise function, so we can ignore stepwise. But you do need to be able to graph your piecewise functions. Graph them and evaluate. And then identifying even and odd functions. So this would be symmetric to the y. And odd would be symmetric to the origin. And then if it's neither of those things, then you just write neither for even or odd. 1.4 was what we just went over, all the shifts in that warm-up. So you need to know the parent functions and then how to shift them all, how to find domain and range, all that stuff. 1.5 was all the processes with functions, how to add, how to subtract, how to multiply, divide, and then find the composition of the functions. So f of g of x and g of f of x. And then don't worry about this. We didn't do anything functions with the Petri dishes or anything like that. We didn't work on that. 1.6 was the inverse function. So you had to use your horizontal line test to figure out if a function was 1-to-1 or if it had an inverse. And then if it was, then you had to find it. So remember, we switched the x and the y. We solved for the new y, and then we plugged the f-1 back in for that y. And then 1.7, don't worry about. We actually did the scatter plots. That was in R.1, but I did not put scatter plots on your test. Okay, so I did give you the odds so that you could check them on Couch Chat, but if any of these need to be worked out while you're here with me, this is what you want to be doing. So any questions from 1.1 from these problems, or 1.2, whatever's really on the screen. Okay, 1.1 was just, like using the equation to find it, and then finding the slope, finding it given a point, finding it giving a point and a line. That was all the 1.1. Emily? 33. Okay, so you're looking to see which one represents the function from A to B. Okay, so if you are, this would be like set A would be your X, set B would be like your Y. And you're trying to figure out which one would be a function. So remember, the function, the X can't repeat with a different Y. So if I look at A, I've got 20 with 4, and then I also have 20 with 6. And that can't work. So this would not be a function. And then I go to B, and I've got 10, 20, 30, and the 4 repeats, which means it's not 1-to-1, but it is a function. Does that make sense? So for a function, you're looking to see if the X repeats with a different Y. If it is, then it does not work. If this was later on, if this was in 1.6, the question might say, is it a function? And if it is a function, is it 1-to-1? It is a function, but B is not 1-to-1, because now the Y can't repeat back with a different X either. Any other question? And remember, from the equations here, to see if it's a function, you're looking to see if the X is raised to an even power or an absolute value. No, if the Y is raised to an even power or an absolute value. The X is your test for 1-to-1. Maddie. So you won't need to, okay? You'll be able to do it from your graph. Technically, you would just see what kind of restrictions the X has, and then how does that impact your Y is what you would be doing. But you'll be asked for domain and range from a graph. Like, because you can do transformations on all those, you could actually probably graph them all, with the exception of like 59, and then see what the range is. But you'll do it from your graph. Okay, any questions on this page, 1, 2? So now we were talking about domain, finding the functions, evaluating the function at the given value. 1, 3, domain and range, vertical line test, increasing, decreasing, relative max, relative min. Make sure that you can graph those functions, okay? So like something, like either, all of these actually, here, 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 here. You would need to be able to graph that on a graphing utility. And then I put all that stuff together into one. So it's going to say, find your domain, your range from your graph, find your max, find your min, find your zeros, figure out if it's even and odd. All that's going to come from the same graphed question, okay? So you're actually going to start with that. You'll come in with your graphing calculator first. I'll warn you now that I'll clear your graphing calculator, so don't have anything in there that you want saved, because I will clear it. And then as soon as that's done, I'll give you the question. You'll start with the calculator. You'll then put your calculator away, and then you'll get the second part from me, okay? So start graphing calculator on a question like that, and then you'll end without the graphing calculator. 53? Sure. Where's 53? Okay, all right, difference quotient. So this is not going to be given to you. You want to make sure that you know what the difference quotient is. That's the memorization part of your test. And then you've got to learn how to apply it. So f of x plus h minus f of x over h would be your difference quotient. So the first thing I'm going to do is find f of x plus h, which means I'm taking f of x, or I'm taking x plus h, and I'm plugging it in to each of the x values. So I get 2x plus h squared plus 3x plus h minus 1. And then I would expand and FOIL this. So the more you do this, the easier it's going to get, because if you've done this a couple of times, you might have memorized what x plus h squared is, which is x squared plus 2xh plus h squared. Plus distribute.
Is it going to be given to us like in the
Nope.
question?
Nope. Everybody here, Nat, she said, is it going to get given to you in the question? It's not. It's just going to say find the difference quotient. distribute the 2. See if I can combine any like terms, and likely there you're not going to be able to. There's not. And then from that, I'm going to do the second part, which is subtract f of x. So all of that minus the original f of x, which is 2x squared plus 3x minus 1. So 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1 minus 2x squared minus 3x plus 1. And then 2x squared, negative 2x squared, 3x, negative 3x, and negative 1 and positive 1. So I have 4xh plus 2h squared plus 3h. And the last step is to put it over h. So all that goes over h. And then simplify. So there is an h in every single term. And I end up here. 4x plus 2h plus 3. Maddie?
So when we subtract the f of x, we distribute that negative?
Yeah, because you're saying subtract every term in here, which means that negative gets distributed to every term.
And then you said that the order doesn't matter.
No, like if you had 2, like technically I think in your book it put it in alphabetical order, so it did 2h plus 4x plus 3. So if this was a multiple choice or something like that, it would be written in that format. But I'm good with that because it's not like you're decreasing a degree, order, or anything like that. So, Pedro. Is it possible? Yeah, like if we didn't have, if there's not a third term sometimes, you won't see that last one. But it hasn't been common, but it is possible for sure. Yeah.
So how would you do it?
So you would just leave it. So if it was 4xh plus 2, let's just say, over h, it would stay like that. 4xh plus 2 over h. You just wouldn't simplify it. Any other questions on difference quotient? And then this page ended on your piecewise functions. Obviously, those are the ones you're going to be doing by hand, so you want to make sure you go with that stuff. This one actually has 2 lines, so it's a little bit easier. You might get a line and a parabola, or a parabola and a square root. It's going to be a combination of them, right? So if I actually just go off the lines, then I would take this and I would say that 3x plus 5 means I have a y-intercept at 5, 4, 5. And I'd go up 1, 2, 3 into the right one, or down 1, 2, 3 into the left one, so that it fits on my graph. And this would have been my original graph. But it's saying that I only want this for the values that are less than 0, right? So this whole side would get erased. And that red dot should actually be an open dot pointing left, because it's less than and not less than or equal to. And then the one on the bottom, y is equal to x minus 4, 1, 2, 3, 4. This time it's a solid dot because it's an or equal to here. My slope is 1, up 1 over 1. And it's greater than, so this line would have run all the way through there. But because it's greater than, it starts at 0 and it goes to positive infinity. So be careful, because remember, this has to be an open dot. If that's not an open dot, this one here, if that was a solid dot, it would fail my vertical line test, which makes it not a function. Okay, a piecewise function is a function, which means, God bless you, one of those, God bless you, has to be an open dot, one has to be a solid dot. I mean,
Do we have to find the domain and range for the piecewise function?
no, but if you did, negative infinity to positive infinity, right? Because even though there's an open dot on one of those y's, there's a solid dot on the bottom. Yep. So as long as there's not a break in your graph, like where there's a space where there's nothing, it's negative infinity to positive infinity.
Why is it a solid dot?
Because it's or equal to here. So that little, the line underneath says I'm including 0 as part of that function, whereas the one in the top, it's saying don't include 0. Start with the very next, so I'm starting with negative 0.000000001 is part of that graph, but 0 is not.
How would we find the range for that?
Range would be bottom to top. So because the arrows point all the way down and all the way up, it would also be all real numbers, or negative infinity to positive infinity.
The top one is like an open knot.
No, because the purple, this side, even though, here, let me zoom out so you see. Like these would continue to go up and these would continue to go down. So it would actually cover all the y's. Go back to.
Doesn't matter that.
All right, how about here? This is your even and odd for 79 and 81. So plug in the negative x to see if it's even. Plug in negative x, negative y to see if it's odd. 1, 4 is what we just did on the warm-up, right? All the transformations. So this one actually gave you the graph and asked you to find the equation. So I know the first one is squared because it's a parabola. I know it's shifted to the right 2 places and up. Looks like 1 place. All right, 1.5 was all the composite functions. So finding f minus g, f plus g, f times h of 1, and then h of g of 5, and f of h of negative 4. So remember with the composite functions, this one I would do h of g of 5. I would find g of 5 first, and then take it and plug it into h. And then 115 f of h of negative 4. So I'd plug negative 4 into the h and then take that answer and plug it into the f. Olivia.
For the f of g and like for f minus g and f plus g, what would you do there?
So you actually have 2 choices. One is, and probably in my opinion the easier one, find f of 4, find g of 4, and then subtract at the end.
Okay.
So just literally plug them in. The other thing to do is find f minus g, so I actually can combine those 2 functions. So I would do 3 minus 2x minus the square root of x. In this case, it's not that complicated. And then plug the values in. So you could do it either way. One way, plug them individually and then subtract what you get at the end. The other way is combine your functions first and then plug the value in. Same thing for 109 and 111. I could have done f of 25 plus g of 25, or I could have added f and g and then plugged the 25 in. And then 111, I could have done f times h. So I'd take the function of f, multiply it times the function of h, distribute it, okay? Or I can plug 1 into f and 1 into h and just multiply the results at the end. So 107 and 109, there's not that big of a difference, but 111, it's obviously going to be a lot more work to FOIL out my 2 functions and then plug the value in than it would have been just to plug in the 1 and then multiply them at the end. So most likely I would go with the plugging in first. All right, and then this was the end of 1.6. So this is your use a graphing utility, figure out the horizontal line test to see if the function is 1-to-1 and if an inverse function exists. So you don't even need, hopefully, the graphing utility to do that. A graphing utility is going to help. But I should be looking to see if, remember, a horizontal line. My x is squared. It's going to fail my horizontal line test. So in this case, 132 would not be 1-to-1, but 131 would. And then 135, you're actually finding the inverse. So that would have been where you change it to y, switch the x's and the y's, and then solve for the new y. Questions on any of those? Okay, so then this is the other one that's in there, okay? This one, same thing. It starts with chapter 1.1, so make sure you're also reviewing R1 and R2. And this one has the answers right on it. So the beginning, you're doing your lines, and then you're finding the equation, checking to see if something is a function based on a graph, evaluating the function, finding the domain of a function from an equation, finding symmetry, so there's the x-axis, the y-axis, and the actual check form. Finding decreasing and increasing. So for 9 and 10 is where the graphing calculator would come into play. 11 and 12 was domain, range, increasing, decreasing, constant, zeros, even, odd, and neither. So if you wanted to highlight 11 and 12, that's like the one you're going to get with your graphing calculator, Okay, so you'll get the function and you'll answer the questions based on your graphing calculator. Make sure you know how to find your max and your min and your zeros on your calculator. It's going to make your life a lot easier. You do not want to spend more than 5 minutes on that question. If you get hung up on that question, it's going to kill the rest of your time. In fact, at some point I'll tell you guys, you need to move on, okay? Because you can't get stuck on it. You want to be able, that should be easy. Let your calculator do the work. All you have to do is learn how to read it, okay? And then your transformations, so I put those on the bottom. They're on the next page, I think. Oh, no. 13. Oh, yeah, right. And then 16, you're finding the composite functions that we kind of just went over. Don't worry about the domain of the composite functions. Make sure you can just read the domain of a simple function. And then 17, 18, and 19 are the inverses. So on your test, as far as your graphing calculator part goes, I wrote on there, you're going to round your answers to the nearest tenth. You're going to give me 1 decimal place. So if my calculator said something was 1.3456789110, you're going to make sure that you just give me the 1.3, okay? Make sure you learn how to round. That's a skill that some of us like have a mental block on.
So we don't need to know how to do the piecewise functions on
On a graphing calculator, no. Yep.
And you're gonna write like round to.
It literally says it on there, like I typed it on there, round to the nearest tenth. I mean,
Where can I find the R1, R2 review for the quiz that you?
it's in files. Oh, no, I didn't. I just went over it. Yeah. 13, 14, and 15 are on that page.